early morning today. Yeah, I see you up there. Good morning, everybody. I'm gonna try to talk to you about what came to me like some years ago when I realized that we as developers have done a lot of things to make our life better, actually. And I think we can be proud of that. And I'm gonna start with a quick intro. My name is Carola Lilienthal, and I'm from Hamburg. So I came yesterday night to Cologne, wonderful weather, and had a beautiful view from my hotel room. In Hamburg, I'm a software architect and managing director of a company of today 170 people, software developer and others. And oh yeah, I thought there would be the picture now, but anyway, I'm gonna keep going here. If you want to find me on the internet, you look for my tag on LinkedIn. You can find me, and on Mastodon as well. Twitter or X is not really my way of communication these days. And I've started as a software developer in the 90s. I studied computer science. I've studied at the University of Hamburg, programmed a lot around 2000. And then I started to become consultant. So I flew around Germany and Austria and other places in Germany. I started to be a trainer, so I gave a lot of trainings about software architecture and so on. And I became an architect, female, as you can see. I found this picture and I liked it a lot. So female architect. And I wrote some books that you might have seen about sustainable software architecture. And this was all only possible because I had a lot of people behind me in my company, WPS. We are sitting in Hamburg, and here you can see all my colleagues when we met last year in summer. Once a year we all meet because we are all over Germany. Corona made it possible that we work remotely, like most of you probably. What I'm going to talk about today is, well, when young people come into our company, there are a lot of young people, as you can see probably, like me as well. When I was young, and still today, we love to program. We love to find out why something is not working. We love to battle ourselves with a machine. I guess all of you enjoy that. But when we get into our first project, I see that with the young people in my company too, all of a sudden there is not just programming, but there are other roles, other people there, and we have to deal with them. And I'm gonna show you a picture now with whom we have to deal, and going to explain to you. So we are up there, like the developers and the architects. And the first people that young developers meet are quality and test managers, quality managers and testers. And they come around with bug reports all the time. You know, this is first thing we have to deal with. Then there are project managers, and they come by with deadlines and plans and all that stuff. And somewhere there are users. When you are young in a first huge project, you even not get to talk to them because they only talk to the project manager. They talk about problems, they have misunderstandings, they have feature ideas. And then there is operations, and they report production problems. So all that happens, and if something goes wrong, there is one person to blame, and that's you, you know? The programmers, it's your fault. If something goes wrong, it's your fault. If there's a bug in the software, the tester will come to you. Well, what did you do? If you're not in time, the project manager will come to you and tell you, it's you, you did it, you know, you didn't do it in quick enough, you know. I go back here. Well, the users, you don't even see them. If something doesn't work as written down or as the user expected, the program manager will come to you as well. Doesn't work. And if the software fails in production, well, you know the story, you know, operations will come to you. It's all our problem. It's always our fault. And I realized one thing: we are trained to find solutions for problems. This is what everybody. I mean, if you go to a party and someone talks about a problem, and some other person right away creates a solution, you can be sure this person is a software developer, because this is what they taught us to be. You know, they taught us to find solutions, and we love that. No, we have a problem, and oh my, what can I do? You even think about it at night, in the morning, under the shower. You have the solution. You know, this is what we know to do. We know to find solutions for problems, and this is not just us. Already, the developers in the 90s, this was their possibility, their ability, their talent. And this is why the developers started to find solutions for all these problems. And actually they started with the first problem up there, with the testers. You know what testers and qualities managers have to do. Being a software tester is a lot like being a detective. You search for all kinds of possibilities to find bugs. And this is a good idea, of course. Testers and quality managers are wonderful. And I'm gonna put some theory in this talk so that you go away with something new. And one thing I want to show you is what people find out about testing and finding bugs. And I'm gonna show you this curve here, and we're going to meditate on it. No, I mean, this is the result of something that Barry Boom in the 90s discovered when he analyzed a lot of software projects. So he took the data from a lot of software projects, and he tried to find out what is expensive. What is expensive? And down there you can see the phases of a software development process. At the beginning you have analysis, then design and implementation, deployment, and maintenance. You know that. You know, this is roughly the phases of a software development process. And on the other axis you see the cost of changes. What does it cost to change something? So to repair a bug. This is a change. And Barry Boom found out that in the beginning, if there is a misunderstanding about the requirements, then to change the requirements on paper, which you do in the analysis phase, is not so expensive. You can just rewrite something. You know, a use case, you can just change it. So when the designer discover mistakes, it's get a bit more expensive. When the developers discover mistakes, it gets even more expensive. But when the testers or the users discover mistakes, this gets really expensive. So Barry Boom said, from this data, you can see that late changes are expensive. This is the point. And, well, on the one hand, we are always blamed, so we have to find a solution. And on the other hand, when the testers find the mistake, it's more expensive than when we do. So what is the solution? Well, 1991, Kent Beck and his fellow were on a plane, and they programmed together. And what did they program? Well, they programmed something that you know. They programmed JUnit at that time. So this was the solution, the first solution to survive in this game. And what we did, developers and architects, because the people who programmed JUnit, they were, of course, programmers. That was not testers. That was some of us. We programmed JUnit to have a first solution towards the quality managers and testers. Today, of course, we have gone further. We have a test pyramid with different kinds of tests. I hope you all do that. Are you doing unit tests? Yeah, okay. You should do that, you know. You should really do that. It's so wonderful. Pardon me? Okay. Oh, that's okay. Okay. You're going to explain to him what this is. But it's so, I mean, most of you might know it's so wonderful to work in a project where there is a lot of unit tests. It's like a security net. And if there is a bug found by someone and reported to you, it's fun. You are happy because you can program another test to find this bug. You can repair your source code, and afterwards you can run all the tests, and you know that the whole thing still works. And this is really, if you have enough tests, you love bugs. This is a very different story than if you don't have them. So just do it, you know. When I talk to young people who finish their studies at the university, I always tell them, if they are trying to get a new job, to ask the question, how many unit tests do you have? How is your percentage in the new company? And when the answer is, oh, well, maybe 10%, don't go there, you know, don't apply, don't take the job, because you're gonna be up at night to save the production or something, yeah? Don't do it, you know. So this is really, really great that we have that. And we have come further. We have today several things that we can do if you have a very bad software system. You know, I'm working a lot with people who have legacy code, bad software. The design is bad, the implementation is bad, and there are many bugs. You can start with testing, of course, to get the system bug-free is never possible. You know that from the theory. It's not possible to have no bugs, but you can reduce the amount of bug with testing. And of course, nobody can write tests for a whole system. Not possible, no? But you can follow the Scout rule. Who knows the Scout rule? Okay, some of you. The Scout rule says that you have to work in your daily programming like a scout when he is leaving a place where he slept, when they put their tents next to a river in the woods somewhere, and they leave the next morning. They have to collect their own rubbish, but as well all the rubbish all the rubbish of whomever has been there before. So they have to leave the place in a better situation than what they found there. And this is your job. When you are fixing a bug, writing some new features, you have to leave the source code in a better situation than as you found it. And one possibility to do that is write a test, write a unit test, okay? Doesn't mean unit tests for everything, but with that you can start. And after a while you will feel a bit safer. Okay, unit testing, good. Then you should have metric tools to get your implementation in a better shape. Who has something like SonarQube in his daily work? Okay, every now and then look at those things that are a bit outside of the normal range, you know? Don't do everything, but huge classes, a lot of coupling, that can help. And on the design and architecture level, there are as well possibilities. There are a lot of tools to look at the architecture. I do that very often. People call me and they need help with their architecture. It's a lot of fun to work on the architecture so that you get a better design and architecture. We go there with tools and we analyze the source code and we discuss with the people how the architecture should be like. This is a lot of fun. It's architecture work in the end. The problem that I always was fighting is to explain to managers, so this is for the salesperson, what to do, you know, how to explain what we are doing and why it's important. And this is why, because with the unit tests, you have percentage. How much tests did I do? With the metric tools, you have numbers as well. But how can I measure the architecture? How can I tell someone that he has a good architecture or a bad one? And this is why we came up with an index. We call it the Modularity Maturity Index to measure whether the architecture is good or bad. You can see here red, yellow, green. If you can see the numbers, the colors, so when you're between 0 and 4, you are bad. In the middle, you are mediocre, and up there, you're good. And these bubbles that you can see here, those are actually the results of several systems. This one up there is a huge system of 15 million lines of code, which is quite good. It got a grade, a Modularity Maturity Index of 8.4. This is the software system of the Techniker Krankenkasse, a well-known insurance in Germany. So if you're insured there, you can stay. You know, the software is in a good shape. I'm not going to talk about the red ones because they are not in a good shape. It's all kinds of languages, you know. It's Java, C#, PHP, C++, and up there is Java. The system of the Techniker Krankenkasse is written in Java, but this one down here, 1 million, is Java 2. So it has nothing to do with the language. It really has to do with the ability, the knowledge of the software developers about good software architecture. So it's very important to learn something about good software architecture, about modularity, about design pattern, and all that. Wherever you can find a book about it, take a course or a training, it will help you to be up there. And this means the software is much easier to maintain, to extend. The other day, someone called me, Carola, can you come and help us? We need someone who looks at our architecture. It's so difficult to get it, to change it. And I said, yes, what do you have? Well, we have 3 million lines of Java code. Well, I said, if you look at the numbers, 3 million is not so big. You can have, I have seen systems of 40 million lines of Java code, so this is all possible, you know. And C# as well, by the way, and C++, of course, too. I said, yeah, okay. How many people are programming this 3 million lines of code? And the person on the other end said, well, we have 30 developers. And I said, sounds reasonable. What is your problem? Well, you know, all these 30 developers, they are all the time, since 2 years, running behind bugs. We can't extend the system anymore. There are new features, but nobody has time to do them. Oh, I said, well, you have a problem. Because for 3 million lines of code, normally 10 to 12 people should be enough for the maintenance. You know, there are always bugs, there are always problems, but 12 should be enough. So at least 18 people should be able to extend the software, to put new features in. So they are probably somewhere down here, like the 2.8, the 3 million down there. You know, they are in a bad situation. The architecture is not good. It's hard to understand. When you have something to do with domain-driven design, you know how we call them, big ball of mud. You know, a horrible monster. Okay, so this is all about metrics, getting your source code into a better shape. Let's face the next problem. Well, the next one that developers and architects went to solve was the problem with the project managers, you know. Because I think all of you know that we all look at software development a bit like this, you know. What is software? A software development process? Well, someone tells us to do something, and then we do a lot of things, and in the end, some great software is coming out. You know, it's all kind of forth and back, rethinking, thinking again, discussing with other people, discussing with the user, and yeah, then we come to a good solution. But when software development got more and more important, like in the end of the 19th century, they put a process on us, which looks a bit like this. You all know that waterfall process, and I want to say, well, at that time, it was actually a good idea because software development was only a small part of huge systems. If you think of sending a rocket to the moon, 69, you know, sending a rocket to the moon, there was software in there, but it was only a little piece in the whole system and helping the hardware to survive, to do what it was supposed to do. And for the hardware, you had to have this process because you have huge things, you need interfaces between big hardware parts, and you can't change them like software in an agile manner. So this was the process for hardware development, and they put it on software, and in the beginning it was right, because they wrote down how the hardware pieces would be, and then they started to construct. This is normal. This is what we do with houses. We have to do it. Otherwise, we will not have this big thing at the end, but, you know, something that doesn't work at all. So for the development in the last century, this was the right process because it was organized in the end. You know, you had to organize it with a lot of people. But for things that were just software development, the software developers, of course, realized that this doesn't work. And this is why we had the Agile Manifesto. You might know it. These days, this is history. We have individuals and interactions over process, working software over documentation, and so on. So this was a historical moment for software development. And for me, it was the moment when it became clear that this cost curve of Barry Boom was wrong. There is a misunderstanding in there. The truth is not that late changes are expensive. You remember, we talked about when you do it in the beginning, because Barry Boom just analyzed waterfall projects. He didn't analyze agile projects. So the mistake here is that late changes are expensive. No, what is expensive is late feedback. Late feedback is expensive because you program something and you know it and it's complicated and you found the solution. And I know all of you, like me, myself, we think, oh, what a wonderful solution I've created here. I will never forget what I programmed. And then a month later, when you have done other stuff, you don't remember. And you look at it and you might remember that you thought you would never forget, but it's gone because so much other stuff came in there. And then it gets really expensive to get back into it and find out why you designed this complicated algorithm there and all those classes stuff. It would have been better to get feedback back at the moment where you were still in there with your head, you know? So this is why we do it like this. Yeah? We do it like this. We have iterations, we have feedback each time, you know? And this reduces the cost fundamentally, but only if you have this feedback cycle. If you program something and very quickly afterwards someone tells you if it's good or not. In the beginning, it's more expensive, of course, because you don't start with a document that you write, but you start with a little bit of software. And that takes more time than rewriting some paper. So agile development was the solution, the Agile Manifesto, towards the project managers. I know that it still today is a problem. It is a problem to get everyone to do it that way. In general, the reason why it's still a problem is that it's so hard for the others to understand that software development is actually an expedition, that we are going somewhere. We know probably that our our goal is to get up on this unbelievably high mountain. We don't know the way. We might come across a river and we can't pass the river, or there is a big mountain drift and we have to find a different way. And this is how software development works. Or we might even think that this is the goal, this mountain, and the actual goal is behind. So software development, like Gernot Starke did it in his book, is like this. At the project start, we think that we're gonna go there. This is our goal, we think. We assume that this is the solution for the project. But it's a bit blurry, you know? We don't really know. Just a guess. And our scope of decision making is quite huge. We can go in different directions. And if we do a little step, just a little prototype, a little MVP of something, then we see all of a sudden, the goal might be there. This might be the solution. And then we redo it. The decision-making scope is a bit smaller, and we do the next one, and you can see it, you can imagine it already, and then the final solution is up there. Oh! And imagine you would have tried to arrive over there. And then you hand it over to the users, and then they say, oh my God, what did you do, you know? And then you have to walk up there with this solution, you have to refactor it. It's horrible, it costs a lot. So don't do it, don't do that. And one thing I see again and again, that people tell me, well, we are doing that, we are completely agile, but actually they do it like that. They do a lot of stories in iterations, and well, the end is not, they don't get down a bit every time, but just at the end. And the problem in there, and I want to point this out to you, is, well, they are doing iterations. Okay, in iteration 1, they do like 4 different things. They present the result to some user or whoever, you know. They say, oh yeah, fine, go on. 2nd iteration, 3rd iteration, 4th iteration. And then finally, the result, there's a release, maybe after 3 months, and they install it, and then there are the users who try it out, and then then the drama starts, and the users say, oh no, but what a misunderstanding. But we showed you, yes, you showed us, but it doesn't work. So this is not agile development, okay? Agile development is like this. You do 1, 2, 3, 4. You install it. And then you ask the other person for feedback. And they have to put a stamp on it, approved. You know, this can stay like that. So imagine 1, 2, 3, 4 is fine. 1, 2, 3 is fine, 4 is a bit of a problem, you know. Then you have your feedback, and then you can redo it, and after the 2nd iteration, 5 is a real problem, but the others are fine. And then you redo 5, 8 is a problem, finally, and then this is agile development, okay? You need feedback and approval after each iteration. I found some very nice pictures to give it another metaphor for you. If you do it the first way, you have iterations, but you don't get approval, you don't get the right feedback, then it's a bit like falling from a window, you know? Oh, I programmed something, I'm flying, ow, bam, you know? This hurts a lot. If you're going iteratively, you fall downstairs. It hurts with each step. It hurts too, but it hurts less, and that's the point. Okay, so this is preferable. It hurts earlier, but this is good, you know, it's good that when it hurts. Okay, let's have a look at the 3rd problem, the users. Well, this was at the same time when 2001 was the Agile Manifesto, as you can see the numbers. This was quite around that same time when we started to use Scrum. And there was this role in there called product owner. This was a great change, a huge change, because all of a sudden we had someone who was responsible for the backlog, who would prioritize it, who would tell us what to do first, who would discuss with us which part of the software we would do, and so on. So this was a good solution. But don't get discouraged. Complex projects are like onions. You have to peel the requirements one layer at a time. And the other person says, yes. And that also makes you cry. Yeah? This is the other side of the it hurts story. So there was already a better situation with the product owners, but there was still a lot of misunderstandings, you know? We still had misunderstandings. What did they want? What did they mean? What did they need? And this is because the source code only shows the understanding of the development of the developers, not the requirements described in a backlog item. This is from Alberto Brandolini, a sentence from one of his speeches. You can write down whatever you want. The product owner can write down user stories and so on. If the developers don't understand what's written down, they will program something that kind of is what they understood, of course. I mean, not kind of, but what is really what they understood. But it's not what the user needs. So this is in 2004 when something entered the scene, which you all might know, it's domain-driven design. Eric Evans was a developer. He came up with domain-driven design to solve this problem, of course. And what did he say? Well, you have to talk a lot. You have to talk. The developers have to talk with the users. They have to speak one language. They have to have the same language. So the domain experts, they are speaking their language, and the developers having their technical language. How should we do it? Well, Eric Evans said, well, this is not good. It's not good if the technical people put their language onto the users. So don't show them any diagrams or database tables or something. Is that what you need? Woohoo, aha. The user can't answer that. So what we need is an understanding in the same language. Of course, you're not going to learn the whole language, but just the part that is necessary for the software. And then you have to transfer it into the source code. Should be, there's a mistake, should be domain lingo in the source code. I'm sorry. There's always one mistake in my slides, you know, and I found it before you. This is good. So what we have to do is we all have to communicate with the same model. When a software developer reads a requirement, a model is formed in his head, a model about what he's going to program, which classes, how they're going to interact, and so on. And this model has to come out of our head, out of our head as developers, and not only as source code, but as something that the user can understand, the domain expert. So we need this shared knowledge and information graphically written and spoken, and it's important to have a language to express this model, and Eric Evans called it the ubiquitous language, which means the language that is everywhere, that is in the source code, in the documents, in emails, everywhere. And this really helps. This really solves the problem, and around that idea, a lot of techniques have been developed to form this ubiquitous language. I hope you have already encountered in your life an event storming, maybe. This is a technique where software developers and users are standing in front of a wall like that, and they're putting stickies on the wall with events that have, with domain events. So the user filled the goods into his carriage. The user is paying. So events from a domain point of view. Or you might have seen domain storytelling, which is as well a technique to discuss with the users what they are doing. this technique focuses more on the roles. So you have the role of a user. You might see the little person on this sticky down there, and you see how they interact, what one person offers to the other, and forth and back. So these techniques are really good to help developers and to help developers to get out the model of their head and show it to the users so they can discuss if this is right. These two techniques belong to a huge number of techniques that are called collaborative modeling. And I was just last week in Munich on the COMO camp, which is a collaborative modeling camp for 3 days. This is really, really wonderful. If you ever want to learn something about that, go there. It's an unconference, so there's no program before. The 120 tickets were sold out in December, I think. So it will be next year in May again, and Vienna is always a good place to go anyway. Look in the internet for COMO camp, and you will see it. It's a huge community and very, very engaged. So when you do that, when you do these collaborative modeling techniques, you will form your own ubiquitous language about this domain, and you will create a bounded context or a context map, a map of the domain parts. And I just show you one from Hamburg, from the harbor, where you have domain-specific contexts for the maneuvers of the huge container vessels, to measure the depth of our river there, because this is the main problem. If these huge container ships want to enter Hamburg, there is the Elbe River, and it's only deep enough for those huge vessels. When the tide is high, you need a tide forecast. And you need, of course, cartography to know where the boats pass. So this is the architecture from a domain point of view for a system that helps ships to get into Hamburg. And the point I want to make is domain-driven design helped us so much to focus on the domain, to have a ubiquitous language. So in 2004, domain-driven design solved that problem for us. We were able to have our direct language with the users. And we were able to root our software in the domain, to have our software mirroring the domain parts, and to get away from that. I don't know if you do things like that. No, you don't, but I like the gig and poke. Okay, so there was one last problem to solve. What are we gonna do with the operations? And you probably have been all living in those times when this problem was solved. We had this problem with the wall in between the developers and the operations, and they called us, your software is not working again. What did you send us? What kind of release did you throw over the wall? And it was again software developers who solved this problem by inventing DevOps, cross-functional teams that need automation, and we implement pipelines today, and we monitor, and we measure, and we supervise. So we finally got into the situation that Dev and Ops started to love each other, at least in organizations where this is done in the right way, as you know. And this was, he doesn't want to go on. This was in 2009, so some time ago. Well, what are we heading to today? What is the future? I spoke about the past, and what is the future? And from my point of view, we have done already a lot. I'm gonna show you a little video, and you can see how things disappear into the computer. I really love that little video. Amazon, books, printer, we had PDF then. The globe is Google Maps. pictures, videos, everything is disappearing. We just stay with computer and sunglasses. Yeah. This is what already happened. Don't throw the thing away, it's important. So you all know what's coming now, is it? You all know that we will have to deal with that thing. This is our future. And for me, it's funny. In the last 50 years, we automated a lot with software. We changed a lot of jobs. And now we are changing our own job. We might lose our jobs because this is a wonderful diagram showing us that, well, we are behind 2023, no? AI is above, so AI started at -100, humans are at 0, you know? And this is when it started. And it was hard for the AI at the beginning. Handwriting recognition, speech recognition. There is image recognition starting in 2010. Very quickly coming up. There is reading comprehensions getting up. Language understanding. And in the back here is predictive reasoning. So we will see what will happen next. I would love to discuss that with you and see your view on that. But I'm gonna end positively. We done a lot, you know, we solved a lot of problems, and I would love to put another line in there about AI sometime. And well, I hope you enjoyed this little motivation speech about what we have all done. And thank you very much for attending.